Imagine asking someone to write an entire essay without once hitting backspace. Sounds tough, right? This is often what we ask AI to do every day and then get upset because it didn't get it right. Yet, Andrew Ng, a pioneer in the AI space, gave a talk at Sequoia Venture Capital about how AI agents perform with a stunning accuracy rate at much cheaper costs. And in today's video, we dig into AI agent design patterns and we show how cheaper models like GPT 3.5 and Llama can match, if not surpass, the performance of their pricier counterparts like GPT-4. Let's watch how AI agents are accomplishing real business tasks and slashing AI costs by up to 90%.
So AI agents, today the way most of us use large language models is like this, with a non-agentic workflow where you type a prompt and generates an answer. And that's a bit like if you ask a person to write an essay on a topic, and I say, please sit down at the keyboard and just type the essay from start to finish without ever using backspace. And despite how hard this is, LMs do it remarkably well.
This is one thing that I think is really important to understand about AI agents. And one of the things that I think is really interesting is that everyone expects them to be far superior than how a human works. Asking a AI agent to write an entire essay, an entire code function without ever hitting a backspace, the fact that it gets it right as many percentage times as it does now is actually amazing. I'm really glad that he pointed that out.
In contrast, with an agentic workflow, this is what it may look like. Have an AI, have an LLM, say, write an essay outline. Do you need to do any web research? If so, let's do that. Then write the first draft, and then read your own first draft and think about what parts need revision. And then revise your draft, and you go on and on. And so this workflow is much more iterative, where you may have the LLM do some thinking, and then revise this article, and then do some more thinking and iterate this through a number of times. And what not many people appreciate is this delivers remarkably better results.
I can tell you from personal experience, just by hand copying and pasting and going through that same flow, that writing a blog outline, especially having this recursive feedback loop, just like you would give an assignment to an employee, write a blog post, you would give them feedback along the way. Let me see the outline. Let me see your research. If you had the time to really collaborate on that, that's what you would be doing with a human. We can do this with an AI and kind of have it collaborate with itself. As you can see, this, revise, research, thinking, it can give its own feedback and revise itself, so that feedback loop, instead of days, weeks, now becomes seconds.
I've actually been really surprised myself working these agent workflows, how well they work. I'm going to do one case study. My team analyzed some data using a coding benchmark called the human eval benchmark, released by OpenAI a few years ago. But this has coding problems like, given a non-empty list of integers, return the sum of all the odd elements or uneven positions. And it turns out the answer is a code snippet like that. So today, a lot of us will use zero-shot prompting, meaning we tell the AI, write the code and have it run on the first.
So Andrew goes on to explain that with this, it is a remarkably better at doing coding, doing blog posts. As you can see here, with GPT 3.5 zero shot on a coding benchmark that it got it right 48% of the time. GPT-4 got it right 67% of the time. That's still not great. However, when you put this AI agent loop of reflecting on its work, revising, and kind of keeping this iterative feedback loop, you can see that GPT 3.5, a model that is 10 times cheaper than GPT-4, can get it right almost the same amount as GPT-4, meaning that the agent model actually improves the logic and reasoning to be able to complete a task. This is amazing research and something that I've seen in my own experience working with AI agents.
And if you were to wrap this type of workflow around GPT-4, it also does very well. And you notice that GPT 3.5 with an agentic workflow actually outperforms GPT-4. And I think this has, and this means that this has significant consequences for I think how we all approach building applications. So agents is a term that's been tossed around a lot. There's a lot of consultant reports talk about agents, the future of AI, blah, blah, blah. I want to be a bit concrete and share with you the broad design patterns I'm seeing in agents. It's a very messy, chaotic space. Tons of research, tons of open source. There's a lot going on, but I try to categorize a bit more concretely what's going on in agents. Reflection is a tool that I think many of us should just use. It just works. Tool use, I think it's more widely appreciated, but actually works pretty well. I think of these as pretty robust technologies. When I use them, I can almost always get them to work well. Planning and
So what he's talking about here, reflection and tool use. So one of the prompting techniques that you can use in just using ChatGPT every day is to have the AI reflect on what it did, or have it reflect on what it did, so that it can revise its own use. Tool use is a newish feature to LLMs, where it can communicate and take action. So it can call APIs to be able to communicate with other pieces of software, or do things like run JavaScript functions or query a database. These types of tools work pretty well right now and are only getting better.
multi-agent collaboration, I think of it as more emerging. When I use them, sometimes my mind is blown for how well they work. But at least at this moment in time, I don't feel like I can always get them to work reliably. So let me walk through these 4 design patterns in the next few slides. And if some of you go back and yourself will ask your engineers to use these, I think you get a productivity boost.
So in terms of planning and multi-agent collaboration, these are emerging technologies. So with planning, you can have it do certain things like think step by step. That's a good prompting technique, where you have the AI say exactly what it's going to do before it does it. And the reason that works is because at the end of the day, these are just very complex autocomplete engines. So if it has its instructions of what it's going to do always in that loop when it's trying to predict the next token or next character to output, it has those instructions that it wrote for itself in that context window. Multi-agent collaboration, this is when you really, really get just the exponential benefits of agents. When they start talking to each other, when you have single purpose agents that's available to only focus on your blog outline, only focus on your research, only focus on critiquing it and making it better, only focused on finding bugs. When you have these very, very single purpose agents all working in unison, which is a very hard thing to get done, it's akin to magic. And I can tell you from personal experience that it can really enhance your workflow productivity.
So reflection, here's an example. Let's say I ask a system, please write code for me for a given task. Then we have a coder agent, just an LLM that you prompt to write code to say, def do task, write a function like that. An example of self-reflection would be if you then prompt the LLM with something like this. Here's code intended for a task, and just give it back the exact same code that it just generated. And then say, check the code carefully for correctness, sound efficiency, good construction criticism. Just write a prompt like that. It turns out the same LLM that you prompted to write the code may be able to spot problems like this bug in line 5, and fix it by blah, blah, blah. And if you now take its own feedback and give it to it and re-prompt it, it may come up with a version 2 of the code that could well work better than the first version. Not guaranteed, but it works, often enough for this to be worth trying for a lot of applications. To foreshadow tool use, if you let it run unit tests, if it fails a unit test, then why did you fail the unit test? Have that conversation and maybe to figure out, fail the unit test, so you should try changing something and come up with V3. By the way, for those of you that want to learn more about these technologies, I'm very excited about them. For each of the 4 sections, I have a little recommended reading section at the bottom that, hopefully gives more references. And again, just to foreshadow multi-agent systems, I've described it as a single coder agent that you prompt to have it, have this conversation with itself. One natural evolution of this idea is instead of a single coder agent, you can have 2 agents, where one is a coder agent and the second is a critic agent. And these could be the same base LM model, but that you prompt in different ways. Where you say, one, you're expert coder, write code. The other one say you're expert code reviewer, so review this code. And this type of workflow is actually pretty easy to implement. I think it's such a very general purpose technology. For a lot of workflows, this would give you a significant boost in the performance of LMs.
So that pattern is something that we put into all of our prompting. So we have AIs checking other AIs. So we always have in a lot of our workflows that we implement, make sure that the output, that the first LLM is critiqued by another prompt looking for specific things, depending on what the goal of the workflow is. So very common technique to be used with advanced workflows.
The second design pattern is tool use. Many of you will already have seen, LLM-based systems using tools. On the left is a screenshot from Copilot. On the right is something that I kind of extracted from GPT-4. But LLMs today, if you ask it what's the best coffee maker, can do a web search for some problems. LLMs will generate code and run code. And it turns out that there are a lot of different tools that many different people are using for analysis, for gathering information, for taking actions, for personal productivity. It turns out a lot of the early work in tool use turned out to be in the computer vision community, because before large language models, LMs, they couldn't do anything with images. So the only option was that the LM generate a function call that could manipulate an image, like generate an image or do object detection or whatever. So if you actually look at literature, it's been interesting how much of the work in tool use seems like it originated from vision, because LMs were blind to images before, GPT-4V and Lava and so on.
I didn't know
so
that.
that's tool use, and it expands what an LM can do. And then planning, for those of you that have not yet played a lot with planning algorithms, I feel like a lot of people talk about the ChatGPT moment where you're, wow, never seen anything like this. I think if you've not used planning algorithms, many people will have a kind of a AI agent. Wow, I couldn't imagine an AI agent doing this. I've run live demos where something failed and the AI agent rerouted around the failure. So I've actually had quite a few of those moments where, wow, can't believe my AI system just did that autonomously. But one example that I adapted from a Hugging GPT paper, you say, please generate an image where a girl is reading a book, and it poses the same as the boy in the image, example.jpg, and please describe the new image with your voice. So give an example like this. Today with AI agents, you can kind of decide, first thing I need to do is determine the pose of the boy. Then find the right model, maybe on Hugging Face, to extract the pose. Then next, need to find a post-image model to synthesize a picture of a girl as following the instructions. Then use image to text, and then finally use text to speech. And today we actually have agents that I don't want to say they work reliably.
I like how it breaks down this specific problem into which AI model or agent would be best for this. So it first determines what the pose is. Then it'll take the image, and now it will take that pose to image, then take that image to text, and then take that text to speech. It's a very, very interesting use case about when you start to break down these problems, how efficient these AI models can be. One of the things that you can do to help enhance its planning capabilities is to give it a lot of context about the agents that you have, what its purpose is, what its goals are, what its inputs are, what its outputs are, so that it can then, you can have an agent that decides which agents to use and in which order. As he goes on to explain, this is still experimental. This is still not getting the types of results that you need for true strategic planning, but we are getting very good results with things like write a blog post that has a clear, definite strategy. Writing a React component on a front end website. These are very small strategic planning tasks that AI is getting better and better at every day.
They're kind of finicky. They don't always work, but when it works, it's actually pretty amazing. But with agentic loops, sometimes you can recover from earlier failures as well. So I find myself already using research agents for some of my work where I'll want a piece of research, but I don't feel like Googling myself and spend a long time. I should send to the research agent, come back in a few minutes and see what it's come up with.
This is one of the very first agents that I ever built was a research agent. I have one that literally lists out the 5 things it wants to research, the questions, a diverse set of questions. It'll go out to the internet. It'll go out to any documents that I feed it and do all the research for me. It's been a huge time saver. And when I put it with other agents, it can help feed that information to blog writers, to white paper, to things that I'm going to be talking about on the YouTube channel. Oh, and I actually have one in the GPT store that you can use, and I'll put the link in the description.
And it sometimes works, sometimes doesn't, right? But that's already a part of my personal workflow. The final design pattern, multi-agent collaboration. This is one of those funny things, but it works much better than you might think. But on the left is a screenshot from a paper called ChatDev, which is completely open, which is actually open source. Many of you saw the flashy social media announcements of demo of a Devin. ChatDev is actually open source. It runs on my laptop, and what ChatDev does is an example of a multi-agent system where you prompt one LLM to sometimes act like the CEO of a software engineering company, sometimes act like a designer, sometimes act like a product manager, sometimes act like a tester. And this flock of agents that you build by prompting an LLM to tell them, you're now a CEO, you're now a software engineer. They collaborate, have an extended conversation so that if you tell it, please develop a game, develop a Go Monkey game, they'll actually spend a few minutes writing code, testing it, iterating, and then generate a surprisingly complex programs. Doesn't always work. I've used it. Sometimes it doesn't work. Sometimes it's amazing. But this technology is really getting better. And just one of the design pattern, it turns out that multi-agent debate, where you have different agents, for example, it could be have ChatGPT and Gemini debate each other. That actually results in a better performance as well. So having multiple simulated AI agents work together has been a powerful design pattern as well. So just to summarize, I think these are the patterns.
That's a really good point too. So it's important that in your AI workflow that you're using lots of different AI models. So instead of having OpenAI's models critique OpenAI output, have OpenAI critique Claude, or have something that's output from Llama being critiqued by Mistral. There's tons of different AI models out there. They all have their inherent biases. They have the data that they were trained on. Just like having a diverse set of ideas, opinions, and background knowledge in a human team, that same sort of diversity is really important for great responses in an AI team or an AI agent team. Are you now curious about the potential of AI agents, but not sure where to begin? Well, we've got you covered. Check out the links in the descriptions and let's explore how you can deploy AI agents in minutes, not months. No matter your skill level, we can enable you to deploy AI agents across your company or for your clients at a fraction of the time. Don't let this complexity hold you back. Let's unlock the future of AI agents together. Till next time.